Thanks for downloading the In Our Time podcast. For more details about In Our Time and for our terms of use, please go to bbc.co.uk/Radio 4. I hope you enjoy the programme. Hello, Johann Wolfgang von Goethe, the great poet and dramatist, is famous for Faust, for the sorrows of young Werther, for Sturm und Drang, and for being a colossus in German literature. Born in the middle of the 18th century, he lived through the first third of the 19th. He wrote lyric and epic verse, literary criticism, prose fiction, translations from 28 languages. He was a politician as well and was hailed by Napoleon as the boundless measure of man. But for much of his time, often to the exclusion of everything else, Goethe was a scientist. He gave us the term morphology, and sometimes he's even credited with inventing biology itself. How important were Goethe's discoveries, and where does he really stand in the history of science? With me to examine Goethe's scientific legacy is Nicholas Boyle, who's just published the second volume of his immense and scholarly biography of Goethe, tremendously well received, called Goethe, the Poet and the Age. Also with me is Simon Schaffer, reader in the History and Philosophy of Science at Cambridge University. What drove him, Nicholas Boyle, to take up science?
Goethe turned to science in his late youth, one might say, after he'd moved to Weimar from his hometown of Frankfurt, and initially his scientific interests related to his responsibilities in the Duchy of Weimar. He took up geology because he was responsible for the local mines. He took up botany because he had to look after the Duke's Park and plant it up with trees. He got interested in anatomy because he reopened the Ducal Drawing Institute, and they started live drawing classes. So the initial interest was practical, but it became an obsession with him. And I think the reason for the obsession was that he was driven to be totally interested in something, and the social and human world about him was perhaps not quite as interesting as the natural world that lay there at his fingertips.
Simon Schaffer, can you give us some idea of the context of Goethe's involvement in science? We expect the Renaissance man to be just that, and Leonardo is an exemplar of that. But by the time of the Enlightenment, by the time Goethe comes along, that seems to have died away. But he seems to have created his own context, as Nicholas Boyle was intimating.
Yeah, I think that's right. For a lot of cultural historians and critics in the German lands and elsewhere, Goethe stands for the possibility at that crucial moment in European, if not world history, of still being in a position to know and do everything across a range of disciplines unimaginable for our own age. But if you go back to, say, 1800, Goethe's projects make sense in the setting of their own time, partly for the reason that Nicholas has already given, that they clearly come out of directly practical reasons of government, of utility within the small German state for which he was responsible. But it's also the case, I think, and Nicholas's books show this wonderfully well, that Goethe makes sure that he's surrounded by the right colleagues. I mean, if one feature characterizes Goethe's work in the sciences, it's a constant and intense discussion through correspondence and often in person with some of the most eminent representatives of each of the sciences and indeed each of the arts with which he's concerned. So I think one way to see Goethe, as indeed to see a lot of the most eminent figures of that epoch, is to, as it were, map the networks in which they're involved.
Can I just stick with you for a second, Simon Schaffer, and ask you, we're just talking about a couple of hundred years ago, and yet a man who was a poet and so on turns his attention to sciences and seems to get somewhere near the heart of several of them. Now, what does that say about the state of science at that time?
I think that it tells you a couple of very important things, which it's well for us to remember now. One is that although the sciences were in a process of specialization, precisely in the years around 1800, they are not yet so specialized that one can't imagine moving between them. But the other thing that's important to remember is that, like all sensible languages, German tends to talk about the sciences, and we suffer from the fact that we talk about science as though there was one singular enterprise which has a single method which can be pursued everywhere. Actually, what distinguishes Goethe's work and those of his immediate allies, is their, I think, really profound understanding that different modes of inquiry require different methods and have different subject matters. And it's precisely because Goethe and his allies understand that they then try to build approaches which link those different sciences together. So there's a kind of paradox. 200 years ago, precisely because scientific and disciplinary specialization and professionalization hasn't nearly reached the stage that it has for us, therefore it was a viable project to, as it were, imagine the unity of the sciences. And I think that's exactly one of the things Goethe was concerned with.
Nicholas Boyle, you said he turned to it at quite a young age. Tell us what he'd done before he turned to science, and what did the disciplines he had done give him when he turned to science in the context of the time?
Well, Goethe started life as a student of law at a university, and as was common, as is still common at German universities, he attended lectures in other subjects. And he went to lectures where the Newtonian theory of light was demonstrated, and he went to medical lectures and that kind of thing. But he didn't really have much of a developed systematic interest in science during the years when he was actually making his literary reputation, when he published the great drama Götz von Berlichingen and the novels The Sorrows of Young Werther that you've mentioned, which made him a celebrity first in Germany and then throughout Europe in the 1770s. It wouldn't really be right to say that he changed to science because his literary activity continued, but it didn't continue unabated. And I think there's no doubt that his literary involvement gradually decreased.
Except for his involvement with Faust.
His involvement with Faust was rather desultory. It came and went. It was very intense in the periods when he did work on it, but then there would be years when he didn't do anything. One of the fascinations of that drama is that, of course, it was completed right at the end of his life, and it acts as a kind of summary of everything that he did throughout that long life, seized in its most intense moments, including, it has to be said, some of his scientific interests as well.
OK, well, let's get down to this science. He took charge of some silver mines and became interested in geology and developed a theory about the age of the Earth. Can you briefly tell us what that is? And I'm going to ask Simon how far that carried.
His particular contribution, his theory in geology, was at this stage, was the theory that not only were rocks crystalline on the small scale, but that the actual large-scale materials or elements that the landscape seems to be built up out of were themselves large crystals. They're now differently explained as shrinkage cracks or fault lines or something like that. But that, I think, would probably be what he saw as his most original contribution to geology. It's a theory of rock shapes.
It wasn't particularly original to tell the kind of story about granite and weathering and the shape of the landscape as a sign of its age. That's not what's original. What I think matters about Goethe's geological work is, as was typical of his work right across the sciences, he was a brilliant synthesizer. He managed to pull together for his immediate audience, at least, a vast number of otherwise unconnected facts, and he managed to turn into accessible prose very esoteric and specialist bits of geological theorizing.
We don't generally regard great synthesizers as necessarily great scientists. We're trying to examine the claim here, huge claims that have been made for Goethe as a scientist and a precursor of some of the very great things that happened in the century after him. So how good was Goethe's contribution, Simon?
I mean, I'd be pretty sceptical about most of the claims which have been made, especially this century, for various reasons, about Goethe as either founder or precursor of the great scientific developments of the Second Scientific Revolution around 1900.
But knocking them off one by one, sticking to geology.
In the case of geology, for example, there's a very large number of people writing in the 1780s and 90s who you begin to be convinced that the Earth is extremely old, much more old than any scriptural account, that the best way of studying the Earth's surface is stratigraphically and by the shape of landscape forms.
Botley up in Cumberland, for instance.
And exactly. And Goethe is clearly one of those. Where one sees his decisive influence is not in brilliant anticipations of what the geological sciences of the 19th century are going to do, but the production of these very intelligent, very lucid overviews. Studying landscape form, for example, turned out to be a key.
I'd like to move from that to the signs of anatomy and the discovery of the existence of the intermaxillary bone in humans. Now, Nicholas Boyle, what was significant about that?
At the time, it was thought that human beings were different from animals, at any rate that the human species was different from other animal species in a way that animal species were not different from each other. And the absence in the human being of a bone between the left and right bones of the upper jaw, a bone which in many animals holds the incisor teeth, was thought to be one of the marks left by the divinity on the human frame to indicate this difference. Goethe's discovery that there were traces in the palate and in the embryo of human beings of such a bone was important to him, and he immediately stated this importance when he made the discovery, precisely because it showed the unity of the human and animals species in the terms of the then theological debate.
This was rejected by anatomists at the time all over Europe, Simon Schaffer. Do you think that they were right to reject it?
I think that they were right by their own lights, in the sense that what Goethe was offering was an extraordinarily ambitious and bold claim built up off of evidence which could be very hotly disputed. What this story about the controversy about the significance of this bone in the upper jaw shows you is that it's often the case that brilliant insights are put forward with extraordinarily little or extremely difficult evidence, and that it's necessary to change the way you argue as well as changing what you're arguing about. This is a really good example of that.
Can we talk about the way he arrived at these theories, which you Simon, you said was ambitious and so on. He used the word Ariadne's thread. I mean, he saw the way forward in his method of science very like the way forward in his method of poetry, whatever it was, which to do with moments of inspiration.
Yes, the metaphor of the Ariadne's thread, the clue that leads you through the labyrinth, is one that occurs again and again in Goethe's scientific writing and also in his writing about his own literary products. He liked to take a single theme, which usually originated in a moment of special insight, as the single structuring principle for a whole literary work or for his approach to an area of scientific study. In the case of geology, it was the shape of rocks. In the case of anatomy, he developed the idea that all bones were metamorphoses of the vertebra, just as in botany all organs of the plant were metamorphoses of the leaf. Such a single structuring idea, which was capable of immense ramification, was what he meant by an Ariadne's thread. But that idea indicates his belonging in some ways, at any rate, to an earlier 18th century way of looking at things. The belief in a great chain of being, which, as far as Goethe and the German context was concerned, derived from Leibniz. This was a belief that the whole order had a rational structure which, at any rate, from God's point of view, was perspicuous. If you were God, you saw all the Ariadne's threads together.
This method is not one which is much followed these days, or great credence is not given to it. Or you're shaking your head, Simon Schaffer.
Yeah, I mean, I think thinking about Goethe's work in what he called zoonomy, what we would call biology, for example, what you're looking at is an entire enterprise which some more fashionable versions of public science nowadays tend, it seems to me, systematically to obscure. Goethe should rightly, for example, be put back as an ancestor of vast areas of natural history, of the descriptive sciences, of that intense concentration on mapping, on describing appearances, on wondering what there is in nature, on a scientific study of form. It's no coincidence that he invents the word morphology as a possible general science of outward description. A lot of our focus, more recently in the 20th and 21st centuries, on evolutionary models, not just for biology but for the sciences in general, has perhaps distracted attention from the importance of natural historical description. And that, I think, is where Goethe fits.
Can I just go back a few years to his demonisation, as it seemed to me, of Newton, his loathing of Newton, and his assault on Newtonian orthodoxy, on the colour theory. Nicholas Boyle, can you tell us, can you give us some background and some detail about that, please?
Yes, Goethe came to colour theory relatively late in his scientific career, that's to say around 1790, after the French Revolution, in fact. And I think this isn't just a coincidence. There was a movement in German thought at this time as a result of philosophy of Kant towards concentration on the individual subject and the way the individual sees the world. And Goethe turned to the science of optics as a science of perception. And this was the fundamental difference, I think, between him and Newton. He felt that Newton was, in his theory of optics, trying to substitute invisible mathematical constructions for the clear evidence of Goethe's own eyes. The idea that white, which to Goethe was the most pure and most basic and most simple visible phenomenon, could somehow be decomposed into colours when colours were so obviously derivative from light and shadow. This seemed to him a denial of the evidence of the senses, a denial of the way things look to us. And this, I think, is the reason for that passionate rejection of Newton, which I think perhaps does have echoes in the subsequent history of science. There have been protests against the mathematisation of our world by natural science, which I think have been able to call on Goethe as a predecessor.
Well, phrases like there have been protests and so on they don't butter many parsnips, really, in the sense of a competition with Newton. Newton's reputation and his findings and what's been built on his findings ever since, which seems to me to be very, very small beer compared with Newton's achievements.
I think that's obviously right. But, again, what Goethe's critique does is to help his own generation understand much, much better what it is of Newton's they should take seriously and what not. The positive content of Goethe's colour theory doesn't seem to me to be nearly as interesting as the way in which, for example, he brilliantly points out, does Goethe, enormous contradictions between what Newton actually said in 1704 in his own work and what popular science teachers of the late 18th century were saying in Newton's name. I mean, I wouldn't draw the contrast between a kind of purely qualitative Goethe theory of optics and a purely mathematical Newtonian theory of optics very sharply. What matters to me, I think, in Goethe's work on colour and light is partly this extraordinarily clever reading of what Newton actually said and the very different interpretations which his successive disciples had given of it. And that turned out to be a very important intervention in colour theory, in optics, and actually in the whole of physics.
Are you then claiming that Goethe's intervention, as you call it, and his pointing out of contradictions had a direct influence on future scientific research in that area?
Absolutely. in several different ways. First of all, it forced the next 2 generations of natural philosophers and physicists to clarify and refine and get clear on what it was that Newtonian optics was supposed to explain, roughly speaking, the physical behaviour of light and colour, and what it up till then simply hadn't addressed, what Goethe called physiological optics or subjective optics, and the emergence of large areas of inquiry which have proved absolutely decisive in the subsequent 200 years, like work on the psychological perception of colour, work on optical illusions, work on after images, on phosphenes, that is to say images you see in your eye after you've been staring at the sun, something both Newton and Goethe loved doing. All that work can be shown, I think, quite directly to flow specifically from what Goethe was doing in the 1790s and 1800s.
Is it true to say, Nicholas Boyle, that that the common principle in Goethe's science is the unity of nature, the links between animals and humans, the way things constantly change slowly over time, this idea of metamorphosis or morphology, which is his term, which Simon Schaffer has referred to, and this has been put forward as a necessary precondition for evolution. Can you spell out any link between Goethe's ideas there and what, let us say, Darwin did?
It's certainly the case, I believe, that early 19th century biological texts routinely refer to Goethe as one of the main authorities on the forms of animals and plants, and in particular on their changeability, on the idea of metamorphoses. Goethe did not have an idea of natural selection, and it's doubtful whether he had an idea of changing species. But I think it's certainly true that he had a very advanced sense of the interaction between the individual and its environment. And in later years, it's also true that, perhaps with a touch of humour, he referred to his own view as hylozoism, that is to say, he thought of the world as itself a living unit. That's an idea that will find an echo nowadays, I think.
But are we talking here about an extraordinary man, a genius, let's use that shorthand, who said things which can, in later stages, be interpreted as giving an indication of what might happen? But just as you can draw out everything, not everything, but a great deal from Shakespeare, say, and so on, in much the same way. Is that what we're talking about, or is what we're talking about a man whose work in science added to the later development of science? Now, this is you can look at this. You know all about this, aren't you? In the case of evolution, is he talking about the unity of the world, the unity of the plants? You know, that's a religious idea. That was in 2,000 years ago, and so on and so on. And before then, and before then, and before then, in Greece, Greek thought, and so on. Is it any different from that? Or is it really part of the trail which led to Darwin?
I think 2 things are going on. First of all, when Darwin's work reaches Germany in the 1860s and 70s, it suddenly becomes extremely important for German intellectuals to find Darwin's German ancestors. And Goethe looks like a very promising candidate, and that's exactly what happens in the 1870s. On the other hand, to fully understand what it was that represented the problems which Darwin, Wallace, and their contemporaries were developing, you do have to think about the work of Goethe and his contemporaries and his allies, because it seems to me you've got to, on the one hand, take the new science of comparative anatomy seriously, without which a whole load of Darwinian questions just wouldn't have been asked. And on the other hand, Darwin's theory is built up on the back of an extraordinarily powerful description of natural objects, of form and growth. And there, it seems to me, Goethe's role, his analysis of how we observe nature, the problem of synesthesia, for example, how different senses can be activated by the same stimulus, the possibility of a science of growth. All that does seem to me to be a completely obvious precondition for the way in which evolutionary biology is subsequently developed.
But his emphasis, Nicholas Boyle, on individual experience does seem out of date as a method, and the idea that he was the father of biology doesn't, I'm being very tentative here, quite understandably, doesn't bear a great deal of examination, would you agree?
I'm not certain that I would make or be in a position to make quite as strong claims for Goethe's role in the subsequent development of science as Simon Schaffer's made. I would only say that to be interested in individual experience is worthwhile, even if it isn't science. And the popularity of ecological thinking these days suggests that there are ways of looking at our world that are not necessarily going to lead to utilitarian, quantifiable benefits, but they are ways of thinking about our relation to the world which are perhaps more literary or more religious than scientific, but they are important to a great many people.
Can I finish, Simon Schaffer, by asking you, let us say that at the very least he did some work which was, you said, a great synthesizer for the time. You make bigger claims of him, and you know a lot better than I do. But do you think that the what Goethe did and encompassed will at all be possible ever again? We're just 200 years on. It's only a few generations. It's a couple of clicks of the fingers. And do you think that is in the slightest bit possible? The span of his mind?
No, I mean, I don't think so. There's an irony about Goethe's individualism, because in his work on botany, and above all in his work on optics and on experimental science, actually it's Goethe who's arguing for collectivism. It's Goethe who says only everybody can know the truth.
Yeah, it's a great sentence.
Which is one of my favourite Goethe apothegms. And it's he who attacks Newton precisely on the grounds, which we may agree with or we may not, that it's Newton who's gone his solitary way. It's Newton who's imposed his solitary authority on the world. And what we now need, Goethe argues, is the collective mobilization of everybody's experience. And I think
I don't think that would make much difference. I don't think that make much difference to the laws of motion or the theory of gravity. I mean, people don't have to vote for that.
No, he isn't talking about voting. I don't see Goethe as
I was using voting metaphorically.
Democratically. But it's Goethe who insists that science is a profoundly collective enterprise, that only if our experience is checked against others, only if experiments are replicable, only if future generations take part in the conversation and the inquiry that we ourselves launch, only if all those conditions are met will the sciences progress. So I see in Goethe's writings actually rather an interesting charter, which is a pretty good description of what happened in the 19th and 20th century. The increasingly large numbers of people involved in the sciences and the increasing dependence of scientific progress on mobilizing actually very large numbers of co-workers. So what's ironic then is that Goethe, who now for us stands as this lone solitary genius, who's like we shall never see again, is the writer who I think much more than most people of his time understood the way in which the sciences were in fact going to develop.
Well, that's an extremely fluent apologia. Thank you very much indeed, Nicholas Bohr, for coming along with your book about Goethe. Thank you both very much indeed, and thanks for listening.
We hope you've enjoyed this Radio 4 podcast. You can find hundreds of other programmes about history, science and philosophy at bbc.co.uk/Radio 4.